This penetrating power of any radioactive emissions decay or disintegration of radioactive element leads to the very dangerous emissions. Well friends, I would like to divert your attention toward the off-life period. What is off-life? Off-life is the time which is required to reduce the quantity of a radioactive element to half of its initial quantity. Half-life is always constant even over the lifetime of the exponential decaying quantity. It is also a characterized unit for the exponential decay equation. This is called exponential law of radioactive decay. dN by dt is equal to minus lambda n, where n is the number of particles left after time t, n0 is the original number of particles, and E is the pure number. For particular decay process, it will always take the same amount of time for number of nuclei to have. The half-life is average time taken for half-life nuclei to decay. Radioactive decay, n is equal to n0 e to the power of minus lambda t. The derivation to the right gives the relationship between the half-life and decay rate. Radioactive decay law. The red line in the graph is a daughter nuclei, and the blue line in the graph gives or represents parent nuclei. On the x-axis time and the y-axis number of nuclei. Similarly, parent nuclei n, half-life period, daughter nuclei d, and it continues. Half-life period and the process, decay process is continuous. Newly formed mineral, if you observe the graph carefully, this is the parent atom. After half-life, it will be like this. Almost 50% of the original atoms are decayed or disintegrated. It is important, the parent atoms and the daughter atoms. The black dots are the parent atoms. Coming to the here, black dots and red dots. Red dots indicates the daughter atoms. Uranium decays slowly by emitting an alpha particle. The half-life of uranium-238 is about 4.47 billion years. Parent excited nuclear state, daughter atom, the emission of gamma radiations. Nuclear stability. Kinetic stability describes the probability that is, a nucleus will undergo decomposition to form a different nucleus. Radioactivity decay. Nuclear stability. Kinetic stability describes the probability that a nucleus will undergo decomposition to form a different nucleus, that is radioactive decay. Thank you friends.